Basic addition.
Actually, kind of, yeah. Chapter 5 is about exponents, polynomials, and polynomial functions. So we're going to ease into 5.1 with exponents and the rules of exponents, which are super easy because they're just about addition and multiplication. So hip hip hooray!
So great.
All right, let's get started. Okay, so in 5.1 we've got a couple of objectives here. There we go. Okay, so we do have a few objectives, but they're not difficult objectives. We're going to use the product rule for exponents. So what do we do when we multiply two exponents? We're going to find zero and negative exponents. We'll use the quotient rule for exponents, use the power rule for exponents, simplify exponential expressions, and use the rules of exponents with scientific notation. So we got 6 objectives to get through. It's Monday. You re-energized.
Finally.
You had 9 days off.
We did?
It didn't feel like 9 days.
I did.
But
But we were at a tour. It wasn't.
Yeah.
We were gone for a while.
okay. So here we go. First objective, use the product rule for exponents. So the product rule for exponents looks like this. If you have, notice please that both of the base values here, do you guys remember the verbiage for these things? No? Here, let's talk about powers real quick. Okay? Let's take some base number. We'll call it b. And if you take that to an exponent, okay? So this is called the base number, or the base, and you take that to an exponent. The whole thing together is called power. Okay, the whole thing together is called power. So I know that before we've said, 3 to the power of, well, I guess that's okay. But just understand, there's 3 different vocabulary words that you need to know here. What the base is, what the exponent is, and what power means all together. So together, those 2 things is power. So, going back to the next slide when we're talking about the exponential rule for multiplication, we've got the same base values. The exponents are different. But if we're going to multiply a to some number times a to some other number, all we have to really do is to add the 2. Go ahead.
Don't the bases have to be the same in order to...
That's why they're both a. So, again, what he's saying is if I've got 3 to the third, and I want to add 2 to the third to that, I can't do that. I mean, technically, I could do that problem, but I can't use my product rule. Okay, does everyone understand why the product rule works? Anybody not? I could explain that real quick, because it wouldn't take very long. And I'm just going to do that for those of you that, okay. What we're saying is that's simply going to be 3 to the 5th. Okay, and if you already know about powers, that's really 3 times 3 times 3, isn't it? Okay, and what we're doing is we're going to add to that. Oh, sorry, this is not add, it's multiply. That didn't make sense to me for a minute. So we're going to multiply by another 3 times 3. And we already know that using our power rule is that I can just write that as 5 by 3 to the 5th. So that's kind of the whole idea behind how that works. Okay, questions there? We're good? All right, moving on. So, what is m to the 8th times m to the 6th? M to the 14th, right? So 8 plus 6 is 14. M to the 5th times p to the 4th? What would that simplify to?
Yeah. The bases are the same.
It simplifies to m to the 5th times p to the 4th. Okay, you can't do anything with it. You leave it alone. Okay. What about negative 5p to the 4th times negative 9p to the 5th? Okay. That one's going to take a little bit of manipulation, isn't it? Okay. So if you take a look at this, everything is being multiplied here. So it's really like having negative 5 times p to the 4th times negative 9 times p to the 5th. Now, do you guys remember that rule about multiplication being commutative? It means I could change it any way I want, right? I could do it in any order, and everything would still be okay. So I can just say that that is -5 times -9 times p to the 4th times p to the 5th, and then I have this situation where that just becomes p to the 9th. And of course, -5 times -9 would be result of positive 45. So that's simply 45 p to the 9th. Or you could just multiply it and know that those are going to get added because you're multiplying them. Okay? Questions there? Okay, how about this bottom one? Can you guys see that okay? Get rid of this. Yay, that worked. So we're going to take care of the whole numbers first, or I should say the integers. -3 times 7, -21. Then I'm going to take a look at x to the second, and here's another x. So that would give me x to the third. And then take a look at the y's. I've got 3 of them here, and 4 of them there, and they are being multiplied, which yields y to the 7th. And we're done. Okay, questions there? Do you see okay from over there, Mike? All right, cool. Any questions here? All right, cool. You look so excited. All right, define 0 and negative exponents. This is a cool idea. Very cool idea. If a is any non-zero real number, that means a can be anything you want it to be except for 0. Okay? It's going to be 1. So anything to the 0 power is equal to 1. So if I said, hey, what's 29 to the 0 power? You'd say, and if I said, what is -29 to the 0 power? 1. And if I said, hey, what's -29 to the 0 power? -1. Why? Well, this one had a negative. You guys remember your protected, unprotected rule? Okay, that negative is inside the parentheses, isn't it? So by a closure, this is all one item. So all of this is to the 0 power. Over here, that negative is not inside parentheses, so you get to cover that up. It's not protected. You take 29 to the 0 power, which becomes 1. Get your hand off of there, and you're going to get a -1. So be careful there. There's a difference, okay? How about 8 to the 0 minus 15 to the 0?
0 is 1 minus 1.
That's 0, because it would be 1 minus 1. Do you see it? This would be 1. This would be 1. So 1 minus 1 is 0. Good. Okay? Now, you really can't have a negative exponent. Okay, you can write them all you want to your heart's content, but you really cannot do that call with a negative number, right? Because when you look at powers, if I said, hey, what's 3 to the second? You're saying, oh, you're going to take that 3 and multiply by itself twice, right? Because that's what the exponent is telling me to do. But how do you explain 3 to the -2? Kind of difficult, isn't it? It's kind of like going in reverse. Okay. So instead of the numbers getting bigger, the numbers are getting smaller. So it's much easier to look at it in the way in the way this rule says. It's really going to be you taking the reciprocal of that. Okay. Now, so if I have a to the -5, that's really going to be 1 over a to the +5. Okay? So it's really just a reciprocal rule. Now, sometimes you're going to get problems where you have a bunch of different things like x to the third, y to the -2nd, z to the 4th, or whatever. Okay? And I say, hey, make that so that's all positive exponents. Okay? Can you take the reciprocal of all that? Should you take the reciprocal of all of that? No, because the only thing that has an issue there is that y, isn't it? The y has a negative exponent. So what I tell people is think about this. You guys remember when we used to solve equations, there was a little rule that said change sign. If you were on one side of the equation, you can pick it up and take it to the other side as long as you change the sign. So if you were positive on the right, you want to move it to the left, it becomes a negative, right? Okay. So I want to kind of reference that. What I would do here is I'd say, oh, that's x to the third, z to the fourth, and this y to the negative 2 needs to go to the other side of the fraction bar. And it's going to look like that. So it's kind of like taking it from the top and to the bottom. If it's negative on the bottom, take it to the top. And that's going to change the sign of your exponent. Okay, same idea, but we're just doing reciprocals, but we're keeping it so that we're not doing, going separating into a fraction, flipping it, and then combining it again. Does that make sense? Odalis? Okay. Now, I've just shown you this, and I kind of explained to you how this works. Can someone tell me how a to the 0 equals 1 works? Josh, you remember? No. Can someone tell me how this works? How is that true then? Okay, because the other one made sense, right? We said it was getting smaller, so it becomes a fraction. Numbers aren't getting bigger. How does that work? Okay. Do I have to prove to anybody that anything over itself is 1? No? Does everyone believe me? Okay, that's kind of like, forget the word for it. I don't want to say it's a fact, but everybody knows that if I take 2 over 2, that's 1, isn't it? 5 over 5, how much is that? 1. So if I took something like 3 to the 5th over 3 to the 5th, what does that equal to? That's equal to 1, correct? Anything over itself is equal to 1. So here's what I want to do. I know that that's already okay, that 3 to the 5th is the way it's supposed to be, right? But I want to show you something. I want to kick it to the top. And if I kick it to the top, what happens to the exponent? It becomes a negative, doesn't it? So now I have 3 to the 5th times 3 to the negative 5th is equal to 1. And a few rules ago, we said, oh, if you have if you have powers with the same base, then what can you do with the exponents? You can just add them, right? So what is 5 plus a negative 5? And there's 3 to the 0 power equals 1. Does that make sense? So that's how anything to the 0 power is equal to 1. You can do that for anything that you kind of create up here in the something over itself. Cool? All right, moving on up. Caution. Yeah, okay. How would you write this with all positives? 1 over 6 to the 5th. How about this? X is not equal to 0 is what it's saying. So we got to keep that rule there, okay? So how would we write this with positive exponents? What is it? 1 over the quantity 2x to the 4th. So quantity, and we keep the rule there because we got to make sure that x is not 0. How about here? Volunteer? A volunteer? Mr. Microphone Man. No?
No speakable content could be found on the screen.
Siri was listening to me?
Yeah.
Go Siri. Got some good ears. -7. Is the -7 an issue here? The -7 doesn't have a negative exponent, does it? So does it need to go anywhere? No, it's that p that has the issue. So p needs to go to the bottom. Okay, as long as p does not equal 0. So there you go. Now, what's the difference between that problem and the problem we just did before? The parentheses. Remember, the parentheses kind of keeps everything bundled together. It's like saying, it's like your little hands, like, oh, you stay together, don't go nowhere. Okay? You stay like that, mijito. Okay. In that case, the -7 was not protected. And there it is. And yeah, don't do this. See, what they're doing is, what they'll do is they'll break it up first into two separate things. What happens when you do that? More work results in more chances for you to make mistakes. Yeah. So don't do that. And then they're multiplying it again. Okay, we could have gone straight from here to there. Hiya. How about this now? Can you evaluate this? That means actually do it. And yes, that's a period, guys, not a decimal point. Just an FYI before I forget, you will not see me Thursday or Friday.
What?
I will not be here Thursday or Friday.
Why?
I'm going to a conference.
What are we doing on Thursday and Friday?
Movie dash?
No.
Oh, that one's a little harsh.
Wait, no,
Movie
really.
days? What are we?
No, really, what are we doing?
Should have watched tonight.
You're not gonna like me.
What?
It starts with a Q.
Wait, on
Quiz?
both days?
No, one day.
Which day?
What's the other day?
Probably Friday.
So what if you're not here?
I'm not gonna be.
No, I'm not here either.
Oh, then you just take it when you come back. Same rules apply.
Wait, wait, and then what are we gonna do the other day?
You'll review. You'll do a review.
Oh, so
It'll all
there's
be on the
interview and
Is it
then...
going to be on this, or are we building off of this and that's on the quiz too?
No, I will not quiz you on anything I have not presented yet. That's
So
not
it's
cool.
gonna be what we learned in the
It'll
next
probably be
meetings.
all exponents.
Oh.
Or if tomorrow we get to polynomials, okay, we'll do some polynomials. Yeah, it's not tough stuff. Anybody have this already?
Is it 1/2? Is it 1/4 minus 1?
So this would be, what would it be? 1/4, right?
Yeah.
Minus 1/2. So if I have a quarter and I take away a half, I'm left with a negative quarter. Okay? Remember, you can't combine those unless you have a common denominator. All right, cool beans. Moving on to the east side. Okay, here we go. Let's take a look at this first one. How do we evaluate 1/4 to the -3rd? Well, the only issue there is that -3rd, right? So I'm going to have to bring that to the top. So this needs to go up here. That makes it 1 times 4 to the 3rd. And of course, you guys already know, right? Some of you guys are going to ignore that 1 already. Because you know 1 times anything is just itself. But that simply becomes, what's 4 times 4? 16. 16 times 4? Thank you. So there's my evaluation of that. That's 64. Okay. Over on the next one, I'm just going to reciprocal this one. This one's okay. Because that's just 9/3 to the 3rd. Now, here's what... This is supposed to be like some kind of segue question, I guess you could say. Wouldn't it be nice if those had the same base? So how can I write 9 besides 9? Couldn't I write it as 3 to the 2nd? Okay, do you guys remember how to do that? Okay, that's the quotient property there. They just subtract, don't they? So I've got 3. If I take 2 away, I'm left with 1. And what's left at the top? 1. So I get 1/3. Okay. You could have also just said 9/27 and simplified 9/27, right? Questions there? All right, cool. So here's the negative rule, special rules. Same idea. Okay, so here's the quotient rule. If you do have powers with the same base, then you can just subtract them. So if I have m minus n, in this case, m minus n. Now, why is there a dot there? Did I leave that there? Oh, it's period. Just kidding. Okay, everybody still remember this guy? So let's talk about how this one works here. So if I have m to the 8th, I have m times 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 m. Correct? Is that correct?
Yeah.
All right, cool. And at the bottom? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We have that, don't we? And what do we know about anything over itself? Oh,
Oh, it equals 1.
it equals 1. Do not say it cancels out. Okay, they don't cancel out. That means that nothing happens to them. And I know that, and it's not your fault. I've heard it for the longest. Okay, and we were kind of taught to say that, right? Oh, they cancel out, they cancel out. That's not true. They simplify. Okay, in this case, I have a 1 here. And 1 times all of that mess is still that mess, isn't it? So of course you guys know what's going to happen. That's a 1, that's a 1, that's a 1, that's a 1. That's a 1, that's a 1, and that's a 1. I think that's what they were trying to tell you, and they look like they were just crossing them out. But those are just a bunch of 1s at an angle. Okay? So what we're left with in the top is 1 times 1 times 1 times 1. And then we've got 1 times 1 times 1 times 1, which we don't need. And I got 1, 2, 3, 4, 5. So m to the 5th. And that's what it simplifies to. Okay? Questions there? I had a professor where we would do these, and he would do those, every single one just like that. Like, it didn't matter if it was like 64 on the denominator. And we would just sit there and just like, we get it. I wanted to do that a couple of times.
A couple.
Couple. Yeah, because then even I get bored. It's like, really, you guys get it. All right, cool. Ah, how about that one? Yeah, that's a -6 and that's a -8. So the first thing I would do is I would flip that. So they get the positives and just ignore the whole idea, okay, in my mind. And I would know that this would be 5 to the 8th over 5 to the 6th, right? And then I say, oh, well, 8 minus 6 is 2. So I'm left with 5 to the 2nd on the numerator. And the denominator, I've just got a 1, which I don't need to divide by. And I'm good to go. Okay, questions there? ¿Qué pasó, Alberto?
I don't know, just your fives make it look like negative.
I know, I'm sorry. That is horrible. I could do better than that. You deserve better than that.
Those look like 5.
Okay? I'm sorry. You deserve better 5s than that. There you go. Are we good? Okay.
This is what makes 5.
How about here? How about here? About. What does this simplify to? It's done. Yeah. Good eye. Good eye, Jacob. Good. No? Too early? Alright. Sorry. The power rules! The power rules are awesome. The power rules. If. Here's your power rule. If you have some power to a power, if you have a power to a power, you're going to multiply the 2. A power to a power, you're going to multiply the 2. So that means if you have like 3 to the 2nd, and that's to the 3rd, then that is simply 3 to the 6th. Tell you why?
Why?
Okay, so if I have, what did I say? 3 to the second, and that's the third, I'm writing this thing how many times? 3 times. So I've got 3 to the second, 3 to the second, times 3 to the second. Ah. Now, this is saying 3 to the second, right? So that's 3 times 3. And then the next one is another 3 times 3. And then the other is also 3 times 3. So if I simplify that, that's simply 3 to the 6th. And that's why it's just easier to say, oh, so now you can just multiply those two. Yeah, make sense?
Makes sense.
Score. Okay. Next one. This is called power of a power. It's called power of a power. That A rule is called power of a power. Rule B, can you see it here? This is the power of a product. This is called the power of a product. Product. Horrible, just horrible. That's the power of a product. Okay? Is that confusing?
No, I still got your pre-done.
I know, my product. It was because the O didn't complete the first time.
I just.
That's a little better. The power of a product. Now, when you have the power of a product, what's really cool about that, it's like your distributive property. You're going to take A to the M and B to the M, like this. So if you have A times B, that's A to the M, B to the M. Okay, and how does that work? Same idea. Let's say I had this. Let's say I had 3x, and that was to the second. Okay, just so we don't, because we don't have a lot of space. Let's say I had 3x to the second. I can just say that is 3 to the second, which is 9, and x to the second. So that's what that would simplify to. Okay? Let me tell you why. Write this 2 times, right? So 3x, 3x. Well, what's 3 times 3? 9. And what's x times x? X squared. So I could do that. If I change that to the third, then this would become 27 x to the third. Because of course I'd have this one more time. 3 times 3 is 9. 9 times 3 is 27. X times x times x is x to the third. The last one is the power of a quotient. The power of a quotient. And it's kind of the same idea as this power of a product. If I have A over B to the M, I can take A to the M and B to the M. Actually, I should, not I can. I must. That reminded me of Cat Dog.
Oh, I love that show.
You guys remember Cat Dog?
Hell yeah. Is that the only?
Not sure he's so scared.
What about Ren and Stimpy?
Yay!
Now they got all these weird cartoons, like they're like awkwardly funny. Like Uncle Grandpa and
What?
Chowder. Yeah.
Ew, Chowder is the
Chowder was
most.
amazing.
I cannot stand that show.
Yeah, they're just annoying. It's called Uncle Grandpa, right?
Yeah, it's like
Incest, yo.
that's insane.
Anyways, how how can I evaluate this? How can I simplify this? This would be r to the 20. Good. 5 times 4. Why did we have to do it twice?
Oh great, she's psycho.
Okay. How about here?
That's incest.
Alberto?
Nope.
Little help?
Are we still multiplying? Have it in my pen.
That's what I'm trying to get you back. Okay? So we're taking every one of these items to the second. So -3, is that negative protected?
Yes.
Yes, because it's inside the parenthesis, right? So -3 squared is a 9. And then y to the 5th to the 2nd is y to the 10th. Okay? And we're done there. Questiones? Someone said wait.
So yeah, it's not gonna be done today.
Good? Okay. Ba, ba, ba. How about here? Careful, yeah. 3 to the 3rd over 4 to the 3rd. Looks just like that. And of course that'd be what, 27 over 60, what'd you say? 64? And we're done. Here?
I'm not getting any money off this, so why am I doing it?
Good eye, Hudson, good eye.
It's time for me.
Okay, we're good?
Oh my god, there's
You can tell me when you're done, thank you. More special rules for negative exponents. Yeah, there's nothing special about these. You're still the same rules. Here, how would we write this with a positive 4? Touche. How can I rewrite this as an equivalent expression so that the 4 is not a negative anymore? It's just a reciprocal, exactly. Just flip that 3 over 2. Okay? Okay, cool. So here's the product rule. We already talked about that. We already talked about the quotient rule. We already talked about the zero exponent rule. Anybody still need to write those down? Moving on. This one's called the negative exponent. These are just the names. Here's the power rules. And this is called the power of a power. This is the power of a product. And this is the quotient of a product. Sorry. The power of a quotient. Okay. Here we go. Let's try this real quick. What should that simplify to? 1 over 4 to the 10th. First we're going to do that multiplication piece. That gives me 4 to the negative 10. To convert that into a positive, I need to make sure that it's reciprocal. And there you go. Which is what, 1 over 400? How about here? Try that. Try that right now. Do it on your, put it in your notes.
Wait. Where is it? Yeah.
What'd you get, Alberto?
1 over x to the second.
Fantastic. Okay. How'd you get that, Jacob?
There you go. You add the -4 and then you say. He asked me.
So you combine all of them since they all have the same base. He went ahead and did, that's going to be x to the negative 10. And then you're multiplying that by x to the 8, which results in x to the negative 2. And to make that a positive, you simply reciprocal that bad boy. Good job, Jacob. Okay, go for C.
Oh.
That's more like what you're going to be doing, right?
God, my notes are everywhere. That's not meant to.
Alberto, get pumped, man. It's Monday. Fresh quarter. You just came back from 9 days off.
Well,
Mr. Munoz, come here. Because right now, I was 16. Well, the test, 0, and then I just read it to 2 games. But I have an interest because there's only 35 now. Yeah, no, you just have to put in the homework and then I just have to do the test. So that's the only reason why.
I still don't understand how.
Not till Thursday.
No, he checked. And we're gonna be done with season Thursday. But
Oh, a lot of sports are ending now, aren't they?
like our last day is Thursday.
Alright, cool. Here we go.
Actually,
In the numerator, m to the second to the negative 2 is going to give you m to the negative 4. And that n will be to the negative 2. That's still over m to the negative 3. N. Everyone okay with that first step? Well, I want to simplify this. Okay? And I want to make sure things end up being positive. So it looks like those two got to go to the bottom, and that's going to have to come up, isn't it? So you're going to get, if I move this down, that's m to the 4th. Take care of that. And I do like to cross them out because sometimes you end up writing it more than once, and that makes you wrong at the end. Not that not doing it is not right. This n to the second needs to come down to the denominator as well. Okay? So I took care of that. This m to the third can come up. And the n is okay, so it's going to just stay there. So take care of that, good to go. Now I can see those have the same base, don't they? So those 3 on the top are going to take out 3 at the bottom. They're going to make 3 1s, leaving me with 1m in the denominator. And then n to the second times n is n to the third. What's left up on top? A 1. And you're good to go.
oh, she's in the office giving. Oh yeah, then you switched out.
How many more slides? Oh, we gotta get to exponents. We gotta get to exponents.
I got one.
What happened?
She said I gotta go home.
We got 10 minutes. Doesn't the bell ring at 9:10?
No.
9:15.
No.
9:10?
Yeah.
Oh, then we got plenty of time.
Oh, is it?
Cool.
It's 9:05.
I would read you all these rules, but they kind of
Don't matter.
they matter, but they are it's easier for me to just tell you. Do you guys remember how to write this in scientific notation? Here's the rule. In order to write something as a decimal, the decimal, as a decimal, in scientific notation, the decimal that we didn't write, or we should have, right, because we know it's there, needs to be in front of the first non-zero digit. What is a non-zero digit, people?
not a 0.
A digit that's not a 0. So, that's a 0, 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 that's not a 0. But is it the first one? No. We read left to right. So the first non-zero digit is this 2. So we need to move this all the way here as 2.98 times 10 to some power. Now you guys know that every time you move a digit, it's a place value, isn't it? So, how many place values did we move? There was 3 there, 6, 7. So that becomes a 7. And you're done. Okay, questions there?
That's it?
No, well, to turn it into scientific notation, we haven't mathed yet. We haven't mathed yet. All we did was make it scientific notation. That wasn't even hard.
That was
Okay, yes, that was math. You're right. But are we okay with this math?
Yes.
Okay, so look at all that. It's too much explaining. Moving on.
Ew, why were there squiggles so ugly? Look at
Oh.
step 2.
I don't know. Okay, how do we make this one scientific notation? In front of the first non-zero, correct? Which is the first non-zero there? The 5. So this should be 5.03. And let's see here. 1, 2, 3. 1, 2, 3. 2. So it goes 3, 6, 7, 8. So that's times 10 to the... Now, yeah, it's going to be a negative 8. And the reason is, this number was really small, wasn't it? We made it bigger. So we got to make sure that this says it was small to begin with. So we got to change that so that it gets smaller again. Negative H, negative ocho. Okay. Goody goody. All right, move on. Like, hey, let's math. Well, that is pretty weird. I think they did it freehand with the mouse. Okay, so now here's the thing. Wow, that is bad. Okay, now how to go back to standard notation. Okay, that's 2.51. How many times bigger does it need to get?
3.
So I'm going to go 1, 2, add a 0 for 3. So 2, 5, 1, 0. Comma goes there, and we're done. Okie dokes. I got this, man. How about this one? So it's, I've got a, let's see, 6, 8, right? And there's a decimal there. And I need to go 5 to the left. So I got to go 1, 2, 3, 4, 5. Put my decimal there, and then I got a 0, 0, 0, 0, 0. So it should be that pretty much with a negative up front, right? Because it's negative 6.8. Come on, slides. Shot, shot, shot. And moving on. Here we go. Let's do some math now. We need to simplify this thing. You see it? It's 200,000 times, whoa, what number is that? 3 tenths, hundreds, thousand, 300 thousandths?
10,000.
Tenths, hundreds, thousand, 10,000ths. I'm sure you're right. He was right. Okay, so we need to first do scientific notation. So this is going to be 2 times 10 to what power? This. What power? 5, thank you. Times 3 times 10 to some power. What power is that? Negative 4, because it's got to end up here. So negative 4 over 6 times 10 to the negative 2. All right, you guys ready? What's 2 times 3? 6. Times 10 to the, what's 10 to the 5th times 10 to the negative 4th? 10 to the 1. What, we don't need to write the 1. And that's over 6 times 10 to the negative 2. What's 6 over 6? 1. Okay. And then that's negative 2, isn't it? So it's got to go to the top because we can't have it be a negative. So times 10 to the second ends up being times 10 to the third. Math. Math. We're done.
That's all we have.
Well, we have one more problem in 4 minutes. These are fun because these are about the sun. And who doesn't like golden sun? I hate that my skin sparkles every time I go out there.
We're Halloween.
The distance to the sun. All right, I'll let you off the hook on this one. Being Monday and all.